as painless as possible, I guess is what I'll say. Okay, so here we go. We're going to take a look at linear functions, okay? And there's a lot of stuff that we, are trying to cover today. So we'll see how this goes. I think it should be fine. Okay. So we'll say this is notes, and we'll say it's a review of linear functions. Okay. Another beautiful thing is the size of this class. Wow, it's so small for an Algebra 2 class. So we are in a very good position here, okay? Even if, well, yeah, this is a very good position for all of us to be in. So we should all do, hopefully, much better with this smaller amount of people in here. Okay, so first thing I want to talk about with lines is I actually want to talk about one part, one aspect, one characteristic of a line, and we'll start with slope. Okay, the slope of a line, right? Slope, or in other words, right, we might know that as the rate of change. Okay, rate of change of a line. Again, starting off real easy stuff. So again, the variable, the letter that we use to typically represent slope is an m, right? A lowercase m. Okay. I'll put that in like quotes to show that that's kind of like the name for it. Slope m. Okay. And we'll say conceptually that's equal to the rise over the run, right? That's one way to do it. How high you go, high or low you go, right? How much you go up or down, and then how much you move left or right to then continue on to another point on the line there. Okay, that's one way so you can count it. Alternatively, right, you also have the formula. y2 minus y1 over x2 minus x1. Right? Now to use this formula, you need some precise points. And so we'll say like x1 comma y1 and x2 comma y2, okay, are points on the line. Okay. So I have some things for us to look at here. Now unfortunately these are not printed out for you, so we'll just have to kind of look at them one by one. Okay. There's slope. So we'll zoom in on one here. So let's zoom in on this guy right here. Okay, so here's a line, right? And we want to find the slope of this line. We want to find that slope. Okay? So any ideas? How might we go about finding the slope of this line using that information we just talked about? Anyone have any strategies? What we can do to find the slope of that line? Like the number value for the slope. The numeric value. Any ideas? Yep. Connor, right? Yep.
Take 2 points from the line.
Okay. Sure, yeah, and if you look here, we have a lot of points, okay? Sometimes we have to be very careful because, like, the way they graph the lines, it might look like a line's crossing at a certain point or not, but it looks like here that this line is crossing at a lot of different points. So we can pick any 2 points here, so I don't know, I'll just pick 2 here. Let's just pick this one right here, okay, and let's just pick, like, this one right here. Okay, those 2. So we pick 2 points, okay, and then what do you do from there, Connor? Do you, what would you like to do from this point then, once we pick these 2 points?
Write down the coordinate pairs.
Okay, so the coordinate pair here, right, would be x-coordinate -3 and then y-coordinate 2. Okay. And then what about for this point right here? Well, let's see, we've got 3 and then -4. Okay. And I'll put that here too, I guess. So maybe from our example, I can zoom out some here. Okay. So, so for an example, we have the point -3, 2, and 3, negative 4 are on the line. Find the slope. Okay, so now that we have those points, those coordinates written out, what would you like to do there, Connor, with those?
Plug them into the formula.
Yeah. Okay, so what's y2 going to be?
-4.
Negative 4, very good. Minus, what's your y1?
2.
2, okay, and then over what minus what?
3 minus -3.
Yeah, very good. Okay, and again, we can put an m equals for the slope equals that. Very good. And we'll simplify. Negative 4 minus 2 is negative 6. 3 minus a negative 3, well, minus a negative, we can make that plus positive, and so we get a positive 6 there, so that simplifies to negative 1 over 1, or if you want, you could just say negative 1. Either one is acceptable there. So yeah, Connor, that's exactly right. That's one way to do it, and probably the most generally useful. Like, if you can just get 2 points, no matter whether you see the picture of the line, like we did here, or whether you just are given 2 points, whatever, then you can find that slope real easily. But since we also have the picture here, what's another option that we have to find that slope? Since we have the picture, what else do we do to find that slope besides like come up with the coordinates? What could we do? What's an easy way to do it? What's that? Yeah, exactly. Just count. Yeah, exactly right. I mean, so I picked these 2 points right here, but I didn't have to use these 2 points. You can use any 2 points, but well, let's just do it. Let's just do it from these 2 points. So to get from here to here, I have to go down 6. So that's a rise of negative 6, and that's a run or go over positive 6, right to the right 6. 1, 2, 3, 4, 5, 6. Okay, so down 6, right 6. Oop, down 6, and then right 6. And so again, it's rise, negative 6, over run, positive 6. And there it is, right? That was in our formula. Rise of negative 6, run of positive 6, you get negative 1 over 1. Okay? So it's there. You can also count it. Okay? So I don't care which method you use. Okay? In fact, it's helpful to know both ways, right? Because then you can use whatever is, most easy for you. Okay. Connor's way is going to be the most generally useful, but what Carlos described is super efficient, much quicker than doing the formula, right? What else do I want to say here? Oh, we also, it doesn't matter which point you start from, right? So we could start from here and go to this point, right? If I do that, it would be a rise of positive 6, but then it would be a run negative 6, because you're going left 6. So it would be plus positive 6 over negative 6, which would still simplify to negative 1 over 1 or negative 1. Or it'd be 1 over negative 1, the same idea. So it's still the same slope. Same slope, no matter which point you count from or in which direction you count. Okay. Good. Very good there. All right, so questions on any of that? I don't want to spend too much time there if that was too easy. Okay. So then, let's have you guys try one here. So you guys try, or actually have you try 2. So again, find the slope. Okay. Of, I'm going to give you a picture here as well. So let's see if I can zoom in on this real good. Maybe I'll do it this way. So find the slope of that line right there. See what you can come up with. Okay. So either you count or use the slope formula or whatever. Take like a few seconds there and find the slope of that line, just on your paper there. Using whatever method you prefer. All right, so volunteers. What's the slope here? Yep. 2 over 3. Okay, and did you use your preferred method of finding 2 points and then calculating the slope using the slope formula? Okay, so what 2 points did you pick out here?
-3, 0.
Okay.
And 0, 2.
Okay, -3, 0, and 0, 2. So you picked out the 2 intercepts for it. Okay, and so yeah, we use the slope formula here. Y2, 2, minus y1, 0, 0 minus then -3, 2 minus 0 is 2, 0 minus -3 is plus positive 3, so it's really just 3. So yep, 2 over 3 would be the slope there. That's exactly right. Okay. And of course you can count it too using those same exact points. Up 2, right 3. Rise of 2, run of 3. So up 2, right 3. Okay, so 2 over 3. Perfect. All right, easy, easy, easy. Let's keep going then. Okay, so we're kind of done talking about slopes there, right? We have some other kind of like, well, we'll get to that here. Let's talk about forms of lines, how to write forms of linear functions. Oops, I'm way zoomed in. There we go. Okay. Alright, so the first form I'm going to talk about is the one you probably are most familiar with. Y equals mx plus b. And what's the name of that form? Remember, what's the name of that form? Nobody? All right, slope-intercept. Slope-intercept. I'm sure you were thinking it. Just didn't want to say it. Okay, right. And again, not very creative title, right? It's called slope-intercept form because when your line, when your linear function is written in this format, okay, when it's written in this format, you are told what the slope and what the y-intercept is. Okay, so if you run across a linear equation that's written this way, you can immediately see what the slope is and what the y-intercept is. Remember that y-intercept is 0, comma, b, right? That's the coordinate of that y-intercept, 0, comma, b, right? The y-intercept is 0, comma, b. Whatever that happens to be. Okay. Very useful, probably the most familiar to you, right? But I'm going to throw another one at you here that I think we should try to be familiar with, and that's point-slope form. Okay. Has anyone not seen point-slope form before? Okay. Should be something you've seen before. So point-slope form, that's y minus y1 equals m times x minus x1. Here, when a line is written in this format, you're told a point that's on your line, and you're told the slope of the line. Okay, so it's like slope-intercept form. Both of you both give you the slope, or both require the slope in order to use them, right? But in this one, in slope-intercept, you need a specific point, the intercept. In fact, the y-intercept, which is like 0b. And this one, you don't need a y-intercept. Any point. Any point. You got that? Okay. The point, okay, is any point on that line. All right, any point on that line. Okay. So, let's take a look at that here then too. Okay. So, let's take a look at an equation of a line here. Let's talk about like y equals, 1/2 x plus 3 there. Okay, so we'll say as an example here, consider the line y equals 1/2 x plus 3. What is the slope? And what is the y-intercept? And I know this is like super basic, but I just want to get through this, and then we'll continue moving on here. Consider the line y equals 1/2 x plus 3. What is the slope? What is the y-intercept? Okay. All right, so let's go to Josh. Is it okay to call you Josh? Okay. Do you prefer Joshua? Joshua. Okay, so Josh, what's the slope of the line here? What's that? What's the slope of that line? Look at the equation there. What can we tell just by looking at that equation? What is the slope of that line? Not sure? Okay, so again, do you recognize what form it's in? What form is it in? Is it slope-intercept form or is it point-slope form? Yeah, slope-intercept, right? Y equals mx plus b, right? Y equals 1/2 x plus b. So, what's the slope? According to this format, right, the slope is the m is the number in front of the x there. What's the slope of this line? 1/2. That's it. You got it. Okay, that's the m. Right. And then what's the y-intercept, Josh? Yeah, as a point. Okay, so you can say either 3, or you can say the actual coordinate there, which would be 0, 3. Right? Again, a y-intercept means it's the 3 for the y coordinate and 0 for the x coordinate. Okay. All right. Let's look at another one. Consider the line 2x minus 6y equals 18. What is the slope? What is the y-intercept? It might be off the screen. Yes, kind of. Okay. 2x minus y equals 18. What is the slope? What is the y-intercept here? So this, believe it or not, 2x minus 6y equals 18, that is a equation for a line, right? If you were to graph that, it would give you a line. Just like that 1/2 x plus 3, if you graph that, that would give you a line as well. Now the y equals 1/2 x plus 3, that's probably easier for us to graph. It's in slope-intercept form. This is a different format. This is actually called standard form. You don't really need to know that, it's okay. But that's a form right there, okay? But it's not in a slope-intercept form, it's not in point-slope form. So how can we go about finding the slope of this line? We don't have a graph, so we can't do what Connor said, which is pick points out right from the graph. So how can we go about finding the slope of this thing? What can we do? Yes? So you want to add 6y to both sides here? Bring it over? Okay, so let me do that over here on the side, okay? So 2x minus 6y equals 18, okay? And we'll add 6y to both sides. Okay. So adding that 6y here cancels out with the negative 6y. So what's left here? Two x equals, yeah, 18 plus 6y. Okay, very good, right? These two things, 18 and 6y, they're not like terms, right? They both don't have a y, and so we want to, we can't add them. We just have to rewrite 18 plus 6y. Okay. So now, from this point, what should we do? Oh, okay. What were you asking? So I shouldn't have added the 6y to both sides? Say again what you. Sorry. Say it again. What you were trying to say.
Like try to make it xy
Equals 2x. Oh, okay. So you want to move the x's over and leave the y where it is. Oh, okay. Okay, I got you. Okay. Sorry, I misunderstood. 2x minus 6y equals 18. So subtract 2x. We have a positive 2x. Get rid of the 2x. And so that's gone. Now we're left with negative 6y, and then 18 minus 2x. Like that. Is that what you meant? Okay, very good. We still have more step to do, though, right? What do we still have to do? Divide by the negative 6. And I'm going to run out of space because I didn't think this through. So I'll go up here. Okay, and so we're left with y equals 18 divided by negative 6. Negative 3. And then we have a negative 2 divided by a negative 6. 1/3, yeah, very good. Positive 1/3, yeah. Negative 2 divided by negative 6, positive 1/3. If like someone minor panic attack because you're like fractions, you can remember if you have a graphing calculator, which is again why I encourage you to have one. You can remember type in negative 2 divided by negative 6, hit enter, you get a decimal, and if you press math enter, it will convert it to the fraction 1/3 there for you. Okay, so if you're like panic attacks about fractions and stuff like that, there it is to help you out. All right. So anyway, all that work. So why did you do that? What can we now say is the slope of this line? 1/3. Yeah, it's the number next to the x. So yep, 1/3 is the slope there, right? And what's the y-intercept of this line? Anybody? Yeah, 0, negative 3. Or you can just say negative 3 if you want to there, to either one. Or the coordinate there is fine. Okay, that's right. Okay, so you have that slope-intercept form there. You have that there for you to like rewrite things, to be able to kind of get things in a format that's more familiar, more comfortable. Okay. All right. Let's talk about parallel and perpendicular lines. Okay, 2. Let's talk about parallel and perpendicular lines. So we'll go to another paper here. Okay. So let's talk about parallel lines. Okay. If two lines are parallel, what do we know is true? They never cross. That's right. They never intersect. Go on forever, yep, not the line. Line's always going forever. So it means they'll never intersect because they're going to keep going in the same direction. What's going to be true about the slopes of parallel lines? Specifically the slopes. They're the same, yes. Parallel lines have the same slope. Okay? But believe it or not, that's not quite enough to make them parallel. Because just having the same slope, we also need to say different y-intercepts. And here's why we have to say that. If two lines have the same slope and the same y-intercept, what's true about those two lines? Well, they do cross, but they're actually what? The same line. So they're going to intersect everywhere, which kind of breaks your definition, right, Carlos, of parallel lines. They should never intersect. And so that's why we have to put that little stipulation in there, okay? That little, exception. Same slope, different y-intercepts. All right. Let's talk about perpendicular lines. Okay. Now, what's special about perpendicular lines? That's okay. Yes, they meet at a right angle, right? That's from geometry. What's true about their slopes? They're not the same, but they're related. What's that? Opposite and reciprocal. You got to flip it too. Yeah. So it's opposite reciprocals, or opposite reciprocal slopes. Okay. Reciprocal, right, is a fancy word for flip, or flipped slopes. So for example, if I have a line that has a slope of 1/2, what is the perpendicular slope to 1/2? Negative what? Not 1/2, negative 2 over 1. You got to flip it too. So if one's positive, the other's negative, but then you got to flip it as well. So negative 2 over 1 is the perpendicular slope. Perpendicular slope. Okay, perpendicular slope. Okay, so let me do an example here. What is the slope of a line parallel to y equals 1, or actually we'll do 2/5 x plus 3. What is the slope of a line parallel to y equals 2/5 x plus 3? Andrew, I'm going to go to you again. 2 over 5, yeah, 2 over 5. Don't even have to put the x in there, just the slope is 2 over 5. Okay, because the slope is really just the number. The x is there, that's, you know, part of one of your variables, but really the slope is just the number, 2/5. Okay, what about, let me just switch it up here. What is the slope of a line perpendicular? It's going to take me longer to write this question than for you guys to solve it. Okay, so sit there and think about that just for a second. Okay, I'll get you this. What is the slope of a line perpendicular to this? Perpendicular to this. Okay. So again, you got to think, like, what's the slope of this line? Okay, and what do I have to do to that to make it a perpendicular slope? So, Carlos, go ahead. What's it going to be? -5 over 2. You got it. Very good. Okay, that's right. Okay. All right. So now let's take a look at writing equations of lines. Okay. And this is kind of like the last thing that we'll look at right here, writing equations of lines. Because this really brings in everything that we just talked about, okay? Taking information. So before, we were given the equation of a line, and we pulled information out of it, right? Before, we were given the equation, y equals 2/5 x plus 3, and we were asking questions, right? We can identify the slope based on that. We can identify the y-intercept based on that. We can do a parallel slope, perpendicular slope. Now we're going to go backwards. We're going to be given some information and then use that to then write the equation of a line. And again, to write the equation of a line, we've got two different formats to use. We have, you know, Old Faithful, y equals mx plus b, right, slope-intercept form. But again, I'm going to introduce you, or reintroduce you maybe to that point-slope form. Okay. Both are useful, and both can be used whenever you want. I mean, unless the directions say use slope-intercept form, or use point-slope form. You can choose whichever one you want to use. If it just says write the equation of a line, either one of these is fine. So, let's say our directions are write the equation of a line given, I'll put like a dot, 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 and then we'll do some different scenarios. Some different kinds of information that we can then use to write the equation of that line. Okay, so let's start with something hopefully not too terrible. Let's go with the slope of that line is, I don't know, we'll say 3, okay, and the y-intercept is, I don't know, 10. Just making some up here. Okay. So given that information alone, we want to write the equation of the line here. So let's see here. So Adam, which form do you prefer here? Or which like, any idea about where to start with this? Or do you have an answer? You have not, what could you say about this one right here? The slope is 3, so that's not the b, that's the m. So we want to use slope-intercept form? Okay. So I'm going to write y equals, what's the m? 3, right? Okay, sorry, I don't know if you're... And then the x, and then what's the b? 10, so it's just plus 10. So it's that easy. Wow. 3x plus 10. So easy, right? We're given what we need. So simple. I don't even know why I had to show that to you. I just felt like, why not? Okay? Alternatively here, right, we could actually use point-slope form. I'll just show you that here real quick. In order to do that, we're going to change that y-intercept of 10 to the actual coordinate. It'll be the coordinate 0, 10. Okay? And so then to use point-slope form, it'll just be y minus, and that y1 is a y-coordinate. So the y-coordinate here is 10. So it's y minus 10 equals m, which is still the same slope that we were using there. It's 3 times x minus, and the x-coordinate there is 0. So this also would be a fine way to write the equation of that line. If I were to guess, though, I mean, even if this were me doing it, I would totally still do this one instead of this. But you can do both. I just want to show you both options there. Because there will be times when that point-slope form will be faster. Okay? Thank you, Adam. All right, let's try another one. Now we're going to write the equation of a line, but I'm going to give you a different situation. So I gave you a slope and a y-intercept. I'm going to give you a different situation. Let's say that we've got a slope of negative 2/3, and the line goes through the point, let's say 6, negative 5. So we're still given a slope, but now instead of being given a y-intercept specifically, we only have a point. Okay. Is this point a y-intercept? Okay. If it's not a y-intercept, how can we tell? How can we tell this is not a y-intercept? I mean, why can't I just use negative 5 as my b, as my y-intercept? Well, how can I tell this point is not a y-intercept? What is it? What do we... Yes, exactly right. The y-intercept must have 0 for the x-coordinate. Because what is a y-intercept, right? Think about it. A y-intercept is where the line crosses the y-axis. All along the y-axis, the x-coordinate is 0, right? If I draw like a little sketch here, right? Any point here on the y-axis, any point here is going to have an x-coordinate of 0. It has to. So this thing is clearly not a y-intercept. So how do we start a problem like this then? Let me go to somebody. Let's pick Patrick. Any ideas about how to start with this? First of all, do you prefer slope-intercept or point-slope?
Slope-intercept.
Sure, fine. All right. So using slope-intercept form, let's plug in stuff that we know. For example, do we know what m is?
Yeah.
What is it? Yeah, so let's plug that in. Negative 2/3. Let's start with what we do know, what goes where we know it's got to go. Okay? We just figured that, okay, so that we don't know the b either. So really all we need, we have the slope, we just need a y-intercept. We've got to find that y-intercept. So one option, we could graph this, could use the slope and then see where it crosses the y-axis, but we could also do it using algebra too. So any idea about how we can use this point here in this equation? Well, I see an x variable and a y variable here, and do these numbers relate to x and y? Yeah, so that 6, for example, where can that go? For which variable? Is it the x-coordinate of the point, or is it the y-coordinate of the point? So it should go in for which variable? Yeah, exactly right. Yeah, not a trick question. And then negative 5 can go in for the y, because it's the y-coordinate. Okay, so we'll plug them in. Plus b, there it is. Okay, plug in the points, in this case. Okay. And now what can we do here? Well, what should be our next step here? Any ideas? Is there something you see? I mean, if you look here, we not only have one variable, and that's the thing we're trying to solve for, so we should probably start solving for that. So, what does this mean to do here? Multiply, right? So, negative 2/3 times 6, which I know it's fractions, I'll do it for you. It's negative 4. Okay? And then what's our final step to get the d by itself? Can you see it okay? What should we do? Not divide. Not multiply. Add. Yeah, just add. Yeah, we want to add. So we have a negative 4 plus b. To get rid of the negative 4, we're going to add 4 to both sides. The negative 4 and the positive 4 cancel out. Negative 5 plus 4 is negative 1 equals b. There's your y-intercept. And so now we can write y equals the slope, negative 2/3 x, minus 1 or plus negative 1, depending on how you prefer. But there it is. If that's comfortable for you, if you get that and you want to just follow that every single time, that's fine. Some of you guys out there, maybe you look at this like, Miss Whitmire, I got this down, no problem, okay? Is there a faster way to do it? Yes, there is. If you use point-slope form, okay, remember point-slope form only requires that you know a point and the slope. Do we know a point? Yeah. And so we can do y minus the y-coordinate there of negative 5 equals m, the slope, whoops, times x minus the x-coordinate there. And that's your answer. We didn't have to do any work to find the y-intercept there because point-slope form only requires that we plug in a slope and a point that's on the line. And we just did. The negative 5 goes for the y1 because it's the y-coordinate of the point. The 6 goes in for the x1 because it's the x-coordinate of that same point. We plug in the slope. No need to solve for b. So it's up to you. You can choose. If this is comfortable to you, do it. I'm showing this to those of you that maybe want to see something different. You get this down, you got this, and maybe you want to try with something different. There's another option right there. Okay, it's faster. All right, I'm going to do some more here. Can I move that? Is that okay? If I'm looking at that. Okay. All right. Let's look at another one here. All right, so we'll do one more, and this one, we're going to do the same directions, write the equation of the line. Write the equation of the line that goes through oh goodness. Actually, hang on a second. I don't like that point. Let me do it this way. Make it easier for myself. That goes through the point 1, 3, and negative 1, negative 4. write the equation of a line that goes through the point, through 1, 3, and -1, -4. Okay, and again, write the equation of a line. That means either slope-intercept form or point-slope form. Okay. So now the question is, how do we start from here, right? Where do we go from here? So, let's go to someone I haven't talked to yet. Someone I haven't talked to. Come on, calculator, give me something good. Man, repeats. All right, so Stacy, any ideas about this one? Where we should start here? On the slope. Awesome. That's exactly where we have to start. In this case, we have no slope. So either the point slope form or slope intercept form both require a slope. We got to find that slope. First thing, find the slope. If you don't have the slope, you got to find the slope. So you did you do -4 minus 3 then?
Yeah.
Okay. Over and then -1 minus 1. Okay, so you get -7 over -2. Ugh, fractions. Negative over a negative is positive 7/2, so I'm going to rewrite that as positive 7 over 2. Okay, we've got a slope, and we have 2 points to pick from. So now at this point, it's just like the problem we did, right? In the problem that we just did, we were given a slope and a point. And so either we had to solve for b now, or we can use point slope form and be done. Okay? Or we can use point slope form and be done. So let's go back to you, Patrick. So Patrick, I got a slope for you, I got a point. We want to find that y-intercept, so let's plug stuff back in. So if I use slope-intercept form here, what can I plug in for that y now?
7 over 2.
Careful, what is that 7 over 2? That's the m. So 7 over 2 is the slope, it's going to go over the slope. So what's a y coordinate, though, we can plug in? Look at your points up here.
-1, -4.
Okay, right, so for the y, which one of those is the y coordinate? So we're going to plug the -4 in for the y. There's another y coordinate you could have chosen. What the other y coordinate you could have chosen? The 3, right. So either one, pick either point you want. I'm going to use the -4 since that's what you said. M is the 7/2. And x. Well, since you chose -4 for the y coordinate, what's the x coordinate you have to use?
-1.
Got to use the -1. Exactly right. I was hoping this wouldn't work out in fractions, but it did. This is what I get for making stuff up off the top of my head. -1 times 7/2 is -7/2. Okay. So to get b by itself here, what would we do to both sides? What's with the b that I need to get rid of? What do I need to get rid of first of all? -7 over 2. Since it's plus b there, I'm going to get rid of this by adding a positive 7/2 to both sides. It was negative, so I'm going to add 7/2 to both sides. That cancels. And then -4 plus 7/2, -4 is the same thing as -8/2. So -8/2 plus 7/2 is -1/2. That's our b. Whew. And so finally we can write y equals 7/2 x, and then -1/2 or plus -1/2 there for the b. Neither one, but there's that, and there's that. Ay, craziness. Or if you use point slope form, y minus -4 equals your m times x minus -1. Don't have to find the b. Saves you that time. Okay, I guess I put that in parentheses there so you just can see. Okay. Of course, or you could have written with the other point too. You could write y minus 3 equals 7 over 2 times x minus 1 there. Okay, either one will work. Any questions on any of that? All right. today was a long day. I apologize. Hopefully that this will not go this long on a regular basis. All right. That's not my intent. I want to be able to give you guys time to get started on homework assignments in class here, because I know when you go home, you know, you're